The next question, which is question 3. The question says in here, 2-pin coral is to be built. The outline of the coral forms two identical adjoining rectangles. So in here we have two identical adjoining. They are sharing the same side. Okay, adjoining, same one side only. Adjoining rectangles. So in here, just a graph prototype. So in here we have the first rectangle. Okay. Okay, that's it. And this is the second rectangle. That's it. So they are sharing the same side, same one side. So in here, if we have this part, for example, let's say the length from here to this point. So they will form at the end, they will form a rectangle again. So in here we have x. This is the same as x. Okay, and if this side is equal to y, that means this side is equal to y and this side is equal to y. Okay, in here, these are the two identical adjoining rectangles. So if there is in here 120 feet of fencing available, so the fencing available for us in here is what? 120 feet. This is the perimeter. All the time the fencing is the perimeter because we need to cover that. Okay, so this is the perimeter. So my perimeter in here is equal to 120 feet. Okay, now you can also use the unit to just that will help you to know if this is area or perimeter. Now if it's feet square, then it will be area. If it's feet, it will be perimeter. If it's cubed, then it will be volume. That's it. So what dimensions of the coral will maximize the enclosed area? So we need to maximize the area. This is my optimization over here. So first of all, I'll put the first relation that I have. The perimeter is equal to the summation of all the sides in your shape. Now in here, this is the first side, the second, third, fourth, fifth. So in here we have x plus y plus y plus y, which means we have 2x plus 3y. Okay, now this is equal to 120. So we need to substitute either the y or the x. So let's take the x over here. So 120 minus 2x equal to 3y. Then after that, I will divide this part by 3. Then this side, the whole side by 3. That's it. This is my substitution. Y is equal to 120 minus 2x. Okay, now we need to maximize the area. The area is equal to x multiplied by y, the length multiplied by the width. So in here, area is equal to x multiplied by 120 minus 2x divided by 3. Okay, now let's simplify it more. So let's enter the x inside. That will give me 120 x, okay, minus, for sure this is divided by 3, okay, minus 2x square divided by 3. Okay, so now this is a. Now after that we can find the derivative directly. Of sure we can in here simplify this. This is going to be 40, so let's write it as simplified form. So this is 40x minus 2 over 3x squared. So now finding a prime, this is equal to be 40 minus 2 over 3 multiplied by 2, which is from the exponent, x, which means in here we have 40 minus 4 over 3x. Okay, now starting directly with finding or making the derivative equal to 0. Now in here for the original function, the domain, it will be from minus infinity to infinity. This is a polynomial. Okay, so the domain is R for the original function. So in here, let's find the zeros for that. So I will take 4 over 3 to this side. So in here, zeros, 40 equal to 4 over 3x. Then after that, I will multiply by 3 and divide by 4. So 3 multiplied by 40, this is equal to 120 divided by 4, this is equal to 30. So that will give me x equal to 30. Okay. Now what about the 30? Is it included with me in the question or not? Now since the domain is R, that means x equal to 30 is included. Okay, so that's it, easy. So let's start with in here graphing the number line. For sure I'm not taking any value for x less than 0. Okay, so it will be from 0 to infinity, and here we have 30. Okay, now let's substitute the values where and the first derivative. So where is that? That's my first derivative. Okay, that's it. That's it. So once you substitute the value, so let's write this in the calculator and substitute any value. So in here, this is my function. So 1, so it will be 40 minus, so this is 4 over 3 x. Then calculate at value less than 30, let's say 2. So this is positive. Okay, let's calculate a value greater than 30, let's say 40. This is negative. So positive, negative. So we have over here positive, negative, which means in here we have increasing, we have decreasing. This is a maximum. So local max at x equal to 30 fit. So let's find the area. Area is equal to what? So I'll go back and see where can I substitute. So I'll substitute in this. So it will be 40 multiplied by 30 minus, okay, 2 over 3x squared. So 2 over 3, 30 squared. I'll calculate that directly in the calculator. So 40 multiplied by 30, okay, then minus 2 over 3 multiplied by 30 square. So this is equal to 600. So this is 600 square. Now after that I can find the value of y also, which is equal to what? 120 minus 2 multiplied by 30 over 3. So this is 120 minus 2 multiplied by 30 divided by 3. So 120 minus 60, which is 60 divided by 3, which is equal to 20. Perfect. That's it. This is my final answer for this question.